All right, so really quick, yesterday you guys talked about identifying the trig values of the values on the unit circle. Today is just still more of that. So like, in case you're referring to what I'm saying, we did for 6.5. We just went and talked about ways to use the unit circle, helpful ways to remember the unit circle. So knowing where things are positive and negative at, then being able to determine the quadrant that they fall in, being able to sketch and model it using the reference angles, then just kind of making sure you knew which reference angles pertain to what. So like my 30-degree reference angles in the quadrants, my 45, my 60s, because again, they're going to have the same sines and cosines and tangents, but just different signs, right? So whether it's negative or positive depends on what quadrant it falls in. Yes? Is that okay? This was yesterday, right? Wrong, right? Yes. All right, then we just practice. So using that knowledge, practice using reference angles and location to solve. That's what the gist of it was yesterday, okay? Today is just a little bit more practice, but without drawing it out. So talking about it in terms of just knowing where things are. So in your brain, this is the conversation you should be having with yourself. 120 degrees. Well, 120 degrees falls into quadrant 2. Agree? So it falls into quadrant 2. So therefore, the reference angle equals 180 minus 120. And 180 minus 120 is 60. So what I'm asking myself, what is the cosecant of 60, right? Cosecant is going to be positive because it's in quadrant 2. So I'm asking myself, what is the positive cosecant of 60 degrees? Okay. This is asking, cosecant is the reciprocal of what? Of sine. Cosecant is the reciprocal of sine. And so at 60 degrees, what is my y value? My y value is, at 60 degrees, the y value isn't it square root of 3 over 2? Yeah, the y value at 60 is square root of 3 over 2. So if I'm square root of 3 over 2, reciprocate it, which becomes 2 over the square root of 3. This isn't rationalized, so I have to rationalize. So that gives us 2 square root of 3 over 3. And that is my exact value for the cosecant of 120 degrees. Okay, there are people in the world who go through this very fast. And if you have to write out your thought process, write it out. No one's expecting you to be like boom, boom, boom in your head, okay? At least not at this point. So again, starting off, what quadrant does 225 fall in? Quadrant 3. So we're in Q3. So my reference angle equals 225 minus 180. Does that make sense? So the reference angle here is 45. In quadrant 3, is cotangent positive or negative? Positive. And tan and cotangent are positive in quadrant 3. So it's positive cotangent of 45. Okay, when you're looking for cotangent, it is x over y, right? The ordered pair of 45 on your unit circle is what? What's the ordered pair for 45? Square root of 2 over 2, square root of 2 over 2. So if I have square root of 2 over 2 divided by square root of 2 over 2, what does that equal? 1. So the cotangent of 225 is 1. Yes? We see where we're going? Again, have we picked up a calculator? No. It has strictly been using the unit circle and your knowledge of the unit circle, okay? Secant of 90. Where is 90? It's on the positive y-axis, right? So since it's on the positive y-axis, that means we're just using its ordered pair. And the ordered pair at 90 is what? 0 and 1. Agree? Secant. Secant is y. Secant is the reciprocal of y. So the secant of 90 equals 1 over my y. What is my y? Oh, it is. I lie. You heard nothing. Brain fart. Thank you, Samuel. 1 over your x. Cos sec. Every c has an s, every s has a c. And what does this mean? Undefined, because what can you have in the denominator? 0. So therefore this is undefined. Because 0 is in the denominator. All right, 7 pi over 4. What quadrant? 4, Q4. Okay, because I'm in quadrant 4, that means in order to find my reference angle, it's going to be 2 pi minus 7 pi over 4. Which equals what? Pi over 4. Okay, in quadrant 4, is secant positive or negative? Positive. So we're looking for the positive secant of pi over 4. Okay, so again, secant is a reciprocal of your x. What is the x value at pi over 4? Square root of 2 over 2. So the reciprocal would be 2 over the square root of 2. And we will rationalize. And we just get square root of 2. All right, 5 pi over 6 for quadrant. Quadrant 2. So in quadrant 2, our reference angle equals pi minus 5 pi over 6. What's our reference angle? 30, which is pi over 6. Is tangent positive or negative in quadrant 2? Negative. So we're looking for the negative tan of pi over 6. Tangent. What is tangent? Y over x. So y divided by x. And so the y of pi over 6 is 1/2. Agreed? And the x is square root of 3 over 2. How do you divide fractions? Keep, change, flip. So we're going to keep the numerator, multiply by the reciprocal of the denominator, which gives us 1 over the square root of 3, which equals square root of 3 over 3. Say what part again? We multiply by the reciprocal. And we get 1 over the square root of 3. We rationalize and we get square root of 3 over 3. That part? You keep the numerator, you change from division to multiplication, and you reciprocate the denominator. Keep, change, flip. Keep, change, and flip. KCF. Okay. Again, when you're dividing fractions with a fraction, you are multiplying the numerator by the reciprocal of the denominator. That's the math terms. Or keep, change, flip. All right. Okay. The last part is just making sure we have an understanding of where things are located based on their signs. So first here it says, I want to know what quadrants will sine theta and cosine theta have the same sign? And what quadrants do they have the same sign? Meaning, when are they both positive and when are they both negative? Quadrant 1 and 3. Okay, next one. I want cotangent and cosine to have opposite signs. Meaning I want one to be positive, one to be negative, or the other be negative and the other be positive. And what quadrants do this happen in? Quadrant 3 and quadrant 4. That's because in quadrant 3, cotangent is positive, and in quadrant 4, cosine is positive, which means they have to obviously be opposites. All right. When you see something like this, remember less than 0. What does that mean I'm asking you for? negative. So when is secant theta negative? Greater than 0 is asking when is something positive. So when is secant theta negative and when is tan theta positive? So one answer. All students take calculus. Where are we at? 3, because we need tan to be what? Positive. All right. Last one, just to check. We're looking for tan theta is negative because it's less than 0. And we're looking for when cosecant theta is greater than 0. So when is it positive? When is cosecant theta positive and tan is negative? 2, quadrant 2. Okay, and that concludes everything in Unit 6.